Good. I feel like you forget something every day just so you can use the elevator, which I've never seen you actually use, so... A trip down the stairs. That sounds like an injury. All right. And we're live! All right, so it's 6th hour. Welcome to math class. It's Thursday all day, which means it's Friday tomorrow, which means you have a quiz. So let's talk about the stuff you totally forgot how to do and show you that it's actually easy and you're going to be fine. And then we're going to talk about the stuff we did yesterday that actually went really well for you guys. So that's going to be great. Yeah, I've been suggesting every class to watch 6 hours video from yesterday because you guys really were cooking. So here's the deal. Let's talk about vectors. Vectors, magnitude and direction, right? Something like that. Awesome. So let's just talk about the first 4. I'm going to pick these ones. I'm going to do it in these colors. That way you can see where I'm going with this. I'm smelling what I am stepping in. So we're going to graph these things. And when we graph vectors, vectors are not about location, right? They're magnitude, direction. Magnitude and direction, right? Magnitude is length. Direction is which way they're going. So it doesn't matter where you put them. It's not about location. It's about movement, right? We're trying to show movement. So when I graph vector v, it's 3, -6, which means 3 in the horizontal direction and 6 down. So I'm going to pick a random point. I'll choose this one. And I'm going to demonstrate that vector by going 3 to the right and 6 down. 1, 2, 3, 4, 5, 6. And there it is. And our vector is heading in this direction, so I'm going to draw my arrowhead on this side. And then when I label it, I'm going to call it vector v, which means I use a little harpoon symbol, right? That's an arrowhead with only half of the arrow, and I'm going to put a V underneath it. So that's vector V. Again, I chose a random point. I went 3 to the right and 6 down. Questions, comments, concerns, other than for my mental well-being. What's that coordinate? I don't know. 2, 4, 6. So it looks like -6, comma 8. Like that. I'm going to keep doing random coordinates. I would like to go through this fairly quickly because the concepts aren't that complex, and then get to the stuff that's more complex in the back of the packet. Yeah. So vector u is 2, -1, meaning 2 to the right and 1 down. So I'm going to choose a random spot, like here, and go 2 to the right and 1 down, and there's our vector u. So again, harpoon symbol and u. Another way to write your vectors is with a little hat, which is adorable, but doesn't really tell you kind of like what they do. I think the harpoon symbol gives you a better idea of what's going on. But we call that u hat, which is fun. Yes? Oh, okay. Fair enough. It does kind of look like a gnome. Oh, that's right, but you will need to sign out in here starting next week. Not my rules, sorry. All right, vector A is 8, 0, which means 8 to the right and 0 up, so here it is.
I can't do this up here, you're too loud.
8 to the right, 1, 2, 3, 4, 5, 6, 7, 8. And that's vector A. Cool, 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 cool. That's vector A. Now I'm going to do vector B, which is -3, 0, which means choose a random point, go 3 to the left, 0 up. That's vector B. How do you feel about graphing vectors? You do their components, horizontal then vertical. Negative means to the left or down. Yeah. So I'm going to leave C and D for you to have fun with at home. Remember, this is not for a grade. It's a review packet. What we need to do now is figure out which ones are parallel. Well, graphing them first helps us eliminate which ones aren't parallel, so we're not testing every single one, right? Those 2 guys, not going to be parallel together, right? These 2 guys, not going to be parallel together. These 2 guys, not parallel. These 2 guys, not parallel, but these 2 are going to be, right? So how do we show that they're parallel? Well, we take their components and we write them in ratio, meaning we write them in fractions. So I'm going to test these 2 to see if they're parallel. They is. There they are. They're their components. So what I do is I write their components kind of like slope, right? Vertical part, horizontal part, vertical part, horizontal part. And we know that 0 divided by anything is, in fact, 0. So these are equal, which means if they are equal in ratio, that means they have the same slope, basically, which means they're going to be parallel, right? So that tells us vector A is congruent to vector B. And not congruent, I should say parallel. Parallel, they are different vectors. Sorry, Rosie.
Mr. Mac, they're holding human legs out there. If you
Yeah?
don't look, they're left.
I'm holding human legs.
No, like,
Right here. The action's here.
without the rest of the body.
Wow, that's impressive. All right. Is that like the sponge?
The leg press, where they go.
Take your leg and you stick it in the air. Take the other leg and stick it right up there.
Weight with this leg and it goes. Have you? I don't think you have.
You failed.
So they're parallel because they're the same, right? Same ratio. 0 over 8 is the same thing as 0 over negative 3. If you were to test the other two, we get negative 1 over 2, which is negative a half. And we get this one, negative 6 over 3, which is negative 2. Negative a half, negative 2, not the same thing, so they're not going to be parallel. Look, they aren't. Now we need to find the magnitude. Magnitude is how long the vector is. So, check it out. Here's vector v. If we want to figure out how long it is, we should break it down into p-fag, make a right triangle, right? We don't need to break it into a right triangle, because guess what? The components are the right triangle. Oh my god, it goes down 6 and over 3. So we're going to use those components in p-fag. P-fag is a squared plus b squared equals c squared. A is going to be 3. B is going to be negative 6. Let's do that. A squared plus b squared equals c squared. And we want regular c, so we root it. That is going to be the magnitude of vector v. So magnitude of vector v is going to be 3 squared plus negative 6 squared. Remember, when we square stuff, it's always going to be positive because a negative times a negative is a positive, and a positive times a positive is a positive. So 3 squared is 9. Negative 6 squared is 36. It's still under the root. We get root 45. That is the magnitude of vector v, how long it is, right? Now, root 45, if you want a rough estimation, root 36 is 6, right? Root 49 is 7, so it's a little less than 7, right? That's how long that guy is. Magnitude. How do we feel about calculating magnitude?
Okay, that's kind of simple.
It's p-fag. It is if you know what you're doing. If you don't know what you're doing, you're absolutely screwed, right? So help me help you know what you're doing.
I shouldn't have showed up so late.
How you feel?
Okay.
Hang on, don't move. Like, you can move, just like don't move the paper.
Oh, okay.
But I have a question on the second part where you found the parallel ones. Can you just put any random pair?
Oh.
Yeah, we're testing to see which ones are parallel.
So if
What?
that mistakenly happens, you can pick those.
Right. So what I would do is I would graph them all first, and then you're able to tell. Can I move this now?
Yeah.
Then you can tell which ones probably are good to test. Like these two, probably parallel, right? These two, not so much. These two, not so much. These.
I'm gonna follow that strategy.
You see what I mean? Right. Find the ones that look parallel, and then test the ones that look that way. Yeah.
I think he just asked from that. How do you know if they're parallel?
So what you do is you write their components in ratio. So vertical over the horizontal, and if they're the same thing, then they're parallel. It's kind of like slope, right? Same slope, both are parallel.
Do you mean vertical, like the 8?
Vertical part, horizontal part. 0 over 8, 0 over negative 3. 0 over anything is going to be 0, right?
So your y is always vertical?
Yep.
Oh, yeah, because the
Yeah,
way,
yeah,
yeah.
cool. That's good. Yeah, you know how to think about it. Ready to turn the page?
Yes,
You're going to want
sir.
to do magnitude and stuff for all of those, which is good because free points, right? Turn the page.
That's easy now.
We're on page 2. It says translate each pre-image by the given vector. Now, the pre-image is the thing you start with. The image is the thing you end up with. I hate that terminology. I wish we just call it pre-image and post-image so we'd have a clear before and after. Write the rule and then write the prime coordinates. You've never seen this format of answering this question because I didn't give you that homework because we were low on time for the last couple weeks, right? But the format should not be confusing. If it is to you, please ask questions. I'll walk you through it. I think it's going to be easier than it looks. So we're going to translate by vector 6, negative 2. Now, translate is not como se dice. What we're doing here is we're moving 6 to the right and 2 down, right? That's what that vector does. It's movement. Vectors are movement. So we're going to apply that to this image. And the way we do that is we go to all the vertices, and we go 6 to the right and 2 down.
Okay, I remember learning that.
So A, 6 to the right, 1, 2, 3, 4, 5, 6, and 2 down is here. So now we're at A prime. The vector that took us there is this green vector right here. This guy, 6, negative 2, right? Pointy brackets,
Do
that's
we
a
have to
vector.
draw the vector from...
Yeah, sure, why not? Do it, please. I don't know. Just fun, otherwise it's too easy. Yeah.
So would the rule just be y plus 6?
Oh, we're going to get there, but you're ahead of me. Yes. 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 Absolutely. So we do the same thing to C. 6 to the right. 1, 2, 3, 4, 5, 6, and 2 down. That's C prime. Vector that takes us there is this. Notice they're all the same vector because they're 6, negative 2, right? Again, you can copy and paste that vector wherever you want. Vectors are movement. B is 6 to the right. 1, 2, 3, 4, 5, 6, and 2 down. So there's B prime. Again, we go towards the prime. Our vector is that. They're all the same vector, just copy and paste it, moving everything. And now to move the entire triangle, what we do is we just connect the dots, right? And there is our translated triangle. It's been shifted over 6 to the right and 2 down. So Caden's right. Our rule is that we take our coordinate, whatever it is, x, y, right? And we shift it 6 to the right, you're right, and 2 down. So that means we took our x and we added 6 to it. And we took our y and we subtracted 2 from it. And that's going to get us the new coordinate, right? You'll notice A is negative 6, 6. where it ends up is 0, 4. And that makes sense because negative 6 plus 6 is 0. 6 minus 2 is 4. Right? So you can check your work, vice versa, with this. Write both.
So this won't be that hard.
Hopefully not. Negative 8 plus 6 is negative 2. Negative 1 plus 6 is negative 5. So that's the horizontal shift on those guys. The vertical shift is minus 2, so we're going down 2. It's going to be at negative 1 and negative 2 respectively. And you can check the coordinates, right? Negative 2, negative 1 is where B prime is. Negative 5, negative 2 is where C is, right? What? Why did I goof? Which one's wrong? Is it this one or this?
You got C. C. It's a C.
I should move the C? It's positive 5. Negative 1 plus 6 is 5. Not negative 5. Just making sure you're paying attention. Cool. Next one's on your own for fun if you want. Remember, this is not for a grade, but you can try it. Any questions on number 2? How you feel about that?
Bueno.
Turn the page. We're still doing vectors. This time, they gave you the before and after, and you need to find the vector that did this thing. So this begs the question. Am I the before or am I the after? You know the commercials where they have the before and after photos? Which one am I?
Good question.
See? All you're supposed to say is after. You can't even lie to me. You guys all have to go like, I don't know.
Andrew,
Thanks a lot.
You deserve a slap in the
All right, so the real question is, before or after? Which one's which? Which one's the before?
Regular number.
Regular A's, yeah. B, C, and D. We're going towards the prime, right? Prime means new. So that was the point of my joke.
Can't you just count how many you take?
So, those are the vectors.
I see we're just making 3D shape here.
Pretty much. So what is...
That's not
Got
that
a
hard.
square.
What is the vector
I don't know.
that takes it from here to here? Well, they're all the same, right? Because it's a slide. Everything gets moved the same amount.
3
So we're going to go 3 to the left. And again, direction matters here. We're starting from B going to B prime. So 3 to the left. I guarantee someone's going to do it the other way. Direction matters. And then we're going to go 6. I'm not 6 up. 10 up is what it looks like.
Good job.
So that means the vector that we applied was negative 3, 10. We applied it to all of the points, including the
Wait, why
vertices.
do you make your things triangles up there? Like where you coordinates?
So the components are the horizontal and vertical part. So horizontally, this thing moved 3 to the left,
Yeah.
and it moved 10 up. I'm just showing you that that's where I got those numbers from.
No,
You don't
I'm
need to
talking
write that.
about there. Like you make them like not normal parentheses. Right?
Oh, because vectors have pointy parentheses,
Alright.
whereas coordinates have this, right? Coordinates are locations. Vectors are movement. So we need to denote between them. But they are very similar, right? You're yawning in math class. Number 5.
I already did it.
Looks like we're going to move to the right or the left. Which way?
Left.
We're moving to the left because we're going towards prime. Do we move up at all? No, so our vertical component's going to be 0, right?
It's going to be negative 12.
Awesome. We also need to find the magnitude for number 4. I forgot about that.
Oh.
So let's do that. How do we find the magnitude?
Well, A squared.
Yeah, we
B squared.
plug those into the Pythagorean theorem to figure out how long this is, right? And that makes sense. 3 here, 10 there. How's this going to be?
Yeah.
So we plug it in and root it. Negative 3 squared, 10 squared. Again, whenever we square something, it's going to come out positive because when you multiply a negative times itself, you get a positive. When you multiply a positive times itself, you get a positive. So negative 3 squared is going to be 9. And 10 squared is hundo, which is what we're keeping it.
I'll look at this.
And we get root 109. Root 109 approximately is a little bit more than 10, right? Because root 100 is 10. So root 109 is just a little bit more.
So Pythag is key.
Yeah, Pythag is how we find the distance, right? How long something is.
So if,
Pythag is distance formula.
if we can root it out to where it's a perfect number, do you want us to do that? Or just
Yeah, so if you get a root 25 for your answer, I would prefer you to write it as 5. Will I mark it wrong? No. Will other teachers? Yes, and understandably so. I won't do it because I don't care.
Yay.
That's dangerous because then if you get the number like the answer is 1, you could, well, let's do something more complicated. The answer is 3. You could write it as 27 over 9, right? Just to be obnoxious, right?
I guess.
And I know you will.
I won't do that.
Just to be
I
that
don't know
guy.
how
Yeah,
hard.
just to be that guy. Like the answer is clearly 3. You had no fractions in the entire problem, and you're right. It's 27 over 9. So now I have to think about it, right? You jerks. That's why teachers like you to simplify. Also, simplifying is good because it helps you understand math better, which is the whole point. Ready to turn the page? Awesome. And it begins. When will
Did
my reflection show? All right.
I say you do.
Here we go.
Student do it.
My friend has a YouTube channel, and his #1 liked video is the song "A Whole New World" from Aladdin, which you get to watch the whole thing, but it's him overdubbed screaming it. So it's "A Whole New World" screamed in parentheses.
Can you like?
Someday, maybe it'll be the song of the day. All right, reflect each point over the given line of reflection. That's what we're doing. We're reflecting this point over this line. Okay? It says first plot the point and the given line of reflection. Okay, well, this is 3 points, not like dots. I mean like points on your quiz. So don't leave this blank. I bet you can graph that and graph that, right?
Yes.
So do that. I'm going to graph this in blue, and it's going to bear a line of reflection. So we're in slope-intercept form, slope of -1, intercept at 4. So I go to 4. 1, 2, 3, 4. There's our y-intercept, and I go down over 1, and there is my line. That's probably the easiest way to graph something when it's in that form, but it's not the only way to graph it. Foreshadowing.
Listen.
There's the line of reflection. How do you feel about graphing the line of reflection?
How'd you
Yeah, man.
how'd you get to the net? How'd you get the other point? I know you got that, but how'd you get
Down 1 over 1 for our slope.
What's his
R?
face?
Because our slope here is -1 over 1,
Yep.
also known as 1 over -1. You can think of it either way, right? Which is also the same thing as negative on the outside, 1 over 1. But it's not the same thing as -1 over -1, because that would be a positive answer. So one of these things is not like the other, and it's that guy, right?
Yeah.
Sounds like the caption under my yearbook photo. So here we are, line of reflection. The point we're flipping is 1, -3, 1 to the right, 3 down. That's point A. We're going to flip that. Remember, reflections always happen perpendicular to the mirror, right? If I'm standing in front of the mirror, mirror me is standing in front of the mirror, not off to the side. That would be weird. So we need to find what's perpendicular to that. So the way we do that is we say, well, the perpendicular line is going to be y equals our perpendicular slope. Now, our original slope is -1 over 1. To find the perpendicular slope, you flip and negate. So we change it by flipping it. 1 over 1 is still 1 over 1 after we flip it.
But it's negative, right?
But it's going to be positive because it used to be negative, right? So we change the sign, and we get 1x instead of -1x. We cool with that? Flip and change the sign. That's perpendicular slope. We don't know what b is because we need to figure out what it has to be in order for the line to go through 1, -3. Right now, this represents all possible perpendicular lines. Here's a line that looks perpendicular. Here's a line that looks perpendicular, right? There's lots of them. As long as they have a slope of 1, they're going to be perpendicular. But we want the line that is perpendicular and goes through this point. So what does it have to do to go through A? Well, it looks like it has to go through -4, if I were to guess, right? Spoilers, it do. We're going to find that out, not by eyeballing it, but by doing math. So we're going to take this point, we're going to plug it in here. This is what we were doing last week, kind of, right? We're going to plug in -3 for y, not for x. -3 goes for y because it's in the y spot, right?
Yes.
And for x, we're going to plug in 1. Then we do math. Looks like 1 times 1 is 1. And then we subtract that 1, and we find out, oh, look, b is -4. Hooray! Which means the perpendicular line's equation is y equals x minus 4. Is everybody cool that 1x is the same thing as x?
Yes.
Same dumb crap, I just plugged in b. It's -4.
Wait, what was that to figure out?
To figure out what b is,
Alright.
right? We're trying to find the equation.
Is the overall goal right now, is there any part of this that, like, trying to figure out when it's going to cross over the x-axis?
Yeah, that's eventually where we're going to get there. Not the x-axis, but where it's going to cross this line, right? How does it flip? Right? So the first step is to find the line that it's going to be on. And we found it. It's -4 for the y-intercept and up 1 over 1 for our slope, right? So A prime, the reflection, is going to be somewhere on that red line. Because all reflections occur perpendicular to the mirror. So A is going to flip over to about here probably. You can kind of eyeball that. But eventually you won't be able to eyeball it because the numbers won't be nice. I'm giving you nice numbers now, that way they're not confusing when you do the math. So you should do the math, get used to it with the nice numbers, and when I switch them out for the awful numbers, it won't be as confusing. Yeah, which will happen. Look at number 10. Good God. So far, here's what we've done. We've graphed the blue line. We've graphed the the green point. Green is the color that is. We took the slope from the original, flipped and negated it, and solved for b to get our red line, which we then graphed. How do you feel so far? David!
Bueno.
How do you feel?
David, you haven't wrote anything
Don't
down.
touch my phone.
Writing stuff down is overrated.
I didn't write anything down.
Don't.
It's
Why?
It's in my folder.
You're not going to look at it anyway. Let's be honest. So,
Yep, I took it.
now we need to figure out where these lines intersect. Well, it looks like they intersect there. Okay, sure. But that's because the numbers are nice. Let's practice finding it just in case the numbers aren't, right? How do we figure out where two lines intersect? With their equations. What do we do with the equations? We set them equal to each other, right? They both equal y, so they should equal each other. Negative x plus 4 should equal x minus 4. The question is where, and that'll be our intersection. How do you solve a problem like Maria? Well, we're going to get our x's together. Terrible idea in real life, great idea in math. I'm going to move over that negative x by adding. So I now have two x's over here. Again, terrible idea in real life, great idea in math. I'm going to take the negative 4, I'm going to add it, and I get 8.
What if you take the other way?
Then you get negative 2x equals negative 8, which would get you the same answer. So I added the negative x and got 2x.
Yes.
A lot of you guys made the x's go away. That wouldn't work. Negative 4, we add it over and get regular 8.
Okay.
Yep. It's okay. Sometimes you just don't see it. It's not because you're dumb. It's just you're not seeing it right now.
Just beat it.
No, I can't
Triangles.
say that.
Right? So now we divide by 2, and we get x equals 4. So our intersection, our midpoint, is going to occur at 4 comma something. How do we find the something?
Plug it in.
We plug it into either equation, because, right, they agree there. So it doesn't matter which one we plug it into.
The easier equation.
When we plug in 4 here, what's 4 minus 4?
0.
0. If we plugged it into the blue equation, we get negative 4 plus 4, which is also 0. It's because they agree there. That's why they intersect. If they don't agree when you plug it in, then you done goofed.
Why couldn't we just count that?
You could have. But now, this is really easy to count because the numbers worked out nicely and I made sure the problem did. But not always will that happen, so let's practice now when the numbers are easy. That way when the numbers get weird, which they will, you'll be okay.
Oh, God.
Awesome, as long as you're not doing it in here. 4, 0 is the intersection.
Yes.
So far, here's what we've done, just to recap, okay? Last time. We found the blue equation, right? There it is, and then we graphed it. We plotted the point. We found the perpendicular slope, flip and negate it. We found b and wrote our equation. That's the perpendicular line. We graphed it. We know a prime is going to be somewhere over here on this red line. We found the intersection, 4, 0, by setting them equal.
Yes.
So we know that's going to be the midpoint, because remember, reflections always occur the same distance on both sides.
Yeah, sure.
So we're going to use midpoint formula now to figure out where a prime exactly will be.
Okay.
So now the last step. First of all, what is midpoint formula?
Y equals the average of the x.
My girl. That's my girl.
Wow.
All right. When we average stuff. Rosie,
What?
do we add or subtract when we average stuff? We add stuff when we average. We're going to average our x's. We're going to have 2 x's, so we divide by 2 because that's the number of pieces.
What?
We're going to average our x's to find the midpoint, otherwise known as the average point, right? We know our midpoint. We just found it. It's 4, 0. So that's what m is. And it's going to equal this coordinate. They're both coordinates, right? They are both coordinates. This part is the x part. That part's the y part. So we're going to average our x's by dividing by 2 and adding our x's together. One of our xy's we don't know. That's what we're looking for. That's going to be a prime's coordinates. The other one is a. We do know that, don't we? A is 1, negative 3. That's our endpoint here. The other endpoint's what we're looking for. That's why it's going to stay xy. And this one's going to be 3, negative 1. Do you see where I got those numbers and why I plugged them in there? Here's the midpoint. It goes for the m.
Yes, sir.
Here and here is our other endpoint, a prime, the thing we're looking for, right? This is what we started with,
Yes.
the original point. We cool with that?
Wait, wouldn't it be 1, negative 3?
It is, thank you. That actually was not on purpose. Good catch. 1, negative 3, because this is 1, negative 3. Alrighty. So now we know that this part of the coordinate is the x part, right? So that should equal this x part. And this part of the coordinate is the y part, so it should equal that. Let's do this in our heads. We know that 4 should equal x plus 1 divided by 2. We want to get x on its own, so we got to get rid of the division and the plus 1. Let's get rid of the division first. How do we get rid of divides by 2? Multiply by 2. When we multiply by 2, the 4 becomes a 8. So now we have 8 equals x plus 1.
Yes.
What do I do to get rid of the plus 1? Subtract. 8 minus 1 is 7. So a prime is going to have 7 for x. Again, what we did is we multiplied by 2 to get 8 and subtracted the 1 to get 7. Then x was on its own. Here,
0.
times by 2, we still get 0.
3.
Add 3, because it's a minus 3, right?
Yep.
Add 3 and we get 3.
Wow.
And that's where a prime is going to be. That last step is the part people get tripped up the most with, and I think it's because you get fatigued by the time you get there. We've done a lot. Right? Don't give up. It's actually not that bad. It's just the last step, and everyone's like tired by then. So 7, 3 is where a prime is. So we go 7 to the left, or 7 to the right. 1, 2, 3, 4, 5, 6, 7, and then 3 up. Hey, look. There she is. That's the reflection. Same distance on both sides, perpendicular to the mirror. How do you feel? Yes?
Oh, how is the 3 not negative anymore?
Multiply it by 2.
Remember we tried.
Still 0.
Remember this time.
That's plus a minus 3, which is just y minus 3, right? How do we get rid of a minus 3?
Remember this now, you got trashed.
Oh.
Yep, it's okay. Thank you for asking.
That's funny. I just had that. I had a flashback.
Are we good?
Yes.
Yeah.
Where
Where does it hurt?
Right there.
You don't know? All right, everybody look up here. Here's what we did to recap.
Yes, it
We graphed the blue line and we graphed the green point. Did you feel good about that?
Sir, yes, sir.
Did you, Sydney?
Okay.
Yeah. I'll help you out.
The slope of this one is negative 1 over 1, yeah? So when we perpendicularize it, we flip it and negate it. We flip it and change the sign, so we're going to get regular 1. Cool with that? Are you cool with our perpendicular slope, Sydney?
Yeah.
How about you, Haley? We need to find b. Well, b is going to be what it needs to be to make 1 produce negative 3, meaning that when we plug in 1 for x, we should get negative 3 for y. So what does it have to be to make that true? Well, we can figure that out by plugging it in. And we found out b has to be negative 4 to make that work, right? So it is. It's minus 4. How do you feel now? Still good? All right. I know these two equations, where they equal each other, is going to be where they intersect. And I need to know that so I can flip it over that point, right? So I set them equal to each other. And I find out where they intersect. I'm going to add that negative x to this and get 2x. I'm going to add that negative 4 to this and get 8. Still good? I'm going to divide by 2 and get 4. So I know they intersect at 4 comma something. I take that 4 and I plug it into either equation to figure out what y is, right? Because if I know what x is, I can get y. So I plug in 4 here. 4 minus 4 is 0. So they intersect at 4 is 0. You could have plugged it in the top. Negative 4 plus 4 is still 0. So that's where they intersect. Are we good up to there? All right. Then we do midpoint formula. We know our midpoint is 4, 0. We just found it. And we know that the midpoint is going to be the middle between these two, right? So we know one of our endpoints is this guy. We were given that.
Yep.
That's 1, negative 3. The other guy we didn't know yet. Good? So now I know this equals 4. They go together. So x plus 1 over 2 equals 4. How do I solve a problem like Maria? I multiply by 2 to both sides. Then I subtract 1. So a prime is 7 comma something. Over here, I know that this equals 0. Y plus a negative 3 is just y minus 3, yeah? Times by 2, I still have 0. Add 3. Here I am. Plot the point. Better? Better? Okay.
Stop spacing out.
Awesome. Thanks for asking.
I said spacing out.
Keaton!
So now? I thought you said so.
Housing gay. bottom.
He's the emperor.
Have the class ask you.
Where does it hurt?
Don't get me wrong, I was
Oh
paying
my.
attention.
No, it's cool, it's cool.
Where was
Do you
it?
know what happened to Evan?
But like,
Graphing these two, feel
I
good?
don't know, it's not just, it's just not clicking.
I'll text you.
Where does it hurt? This is, oh, sorry.
Yeah.
Graphing these two, fine, right?
Yeah.
Finding the perpendicular slope, flipping and changing the sign.
Yeah.
That's the original, right? Plugging in the point, getting B.
Yes.
So it must be this.
Yes.
Set them equal.
Are
Are
you
you
kidding?
kidding?
All right, shut up so I can talk.
It's fine. It's fine.
No, it's not.
I have it figured out.
Where did it hurt?
I have it figured out.
Where did it hurt?
It clicked
Where did it hurt?
everywhere.
Liar. These two are put together. 4. Add the x, get 2x, add the 4, get 8. Divide by 2, get 4. 4. Plug it back in, get 0. That's where they intersect. Use the midpoint to flip the point. Here's midpoint. I know midpoint is 4, 0 now. I know that this x and y is what I'm looking for. And this x and y is this guy. 1 comma negative 3. So I plug in 1 and negative 3 here. Times by 2, get 8. Subtract 1, get 7. Times by 2, get 0. Add 3, get 3. Is the last step what's tricking you?
Yeah.
This equals 4. So I write that. Times by 2, I get 8. Yes?
Yeah.
Is that where it's tripping you up?
Yeah.
Okay. X plus 1 divided by 2. How do I get rid of divided by 2?
Multiply by the reciprocal.
Oh, nope. Don't need to multiply by reciprocal. How do I get rid of divides by 2?
Multiply by 2.
Yeah. So I multiply by 2 and I get 8. And then I subtract 1 and I get 7.
Okay.
Is that okay?
Yeah.
All right. Same thing over here. This equals 0. I double it, right? I multiply by 2 and I still get 0. And then I add 3. Better?
Yeah.
Okay, I'll take better. Seven. You're not going to write anything. Absolutely nothing.
Nothing.
I have
Write absolutely nothing. Good job, Rosie.
Put it right in front of you.
Here we go.
That is perceptual.
All right. Here is 7. First off, buckle up. I'll do it quickly because if I do it too slowly, you'll zone out. Let's be honest.
Yep.
Keep you engaged. So here we go.
Did you read it?
Get loose, get limber, don't pull hammy.
What are you gonna do about it?
Nothing. I'm just gonna tell you. Forward.
All right. So first I'm going to graph this line. This line is in slope-intercept form, meaning the slope is 1, right? And the y-intercept is negative 3. Negative 3 for the y-intercept. I go up 1 over 1. Here's my line. I'm running out of patience, so I'm going to draw it right now. There's the line. Slope is 1 over 1. Y-intercept is minus 3. So far, so good.
Sir,
Yes,
yes,
sir.
sir.
A is negative 2, negative 11. So I'm going to go down, or 2 to the left and down 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's A. Right there. I know it's 12 by 12, so I cheated. All right, so that's A. Everybody good with that? Awesome. Now I'm going to find the perpendicular line. Perpendicular lines have perpendicular slope. Yeah, it's not going to work. Let's just do this. Regular slope is 1. 1 over 1, right? Flip it, still 1 over 1. Change the sign. Now it's negative. Negative x, if you will, right?
Yes.
B value. Don't know what it is. I got to figure it out. Depends on what this is, right? So I plug that in. Negative 2 for the x. Negative 11 for the y. Whenever you plug stuff in, you wrap it in parentheses. That way you remember to get the double negative. Right? Double negative means it's positive. We subtract 2, we get negative 13 for b, which means our equation is y equals negative x minus 13. Are we cool with that? That is the perpendicular line. I'm going to graph it now. Here's the problem. If I go down negative 13, I run out of room. So I need to be clever.
Pick a point.
I know that A is going to be on that line, right? That's how I made the line. So I can use my slope, which is minus 1, and just go down from there, down 1 over 1. So there's my line. Now, either I drew my line really poorly or this is going to have a weird intersection. We're going to have to find out, right? Because that looks gross. So hopefully it's not weird.
Disgusting.
Disgusting.
Look like my ex-wife.
So now let's figure out where they intersect. Hopefully it's a nice point and I just drew my line really poorly. The way we do that is we take the two equations, the original and this guy, and we set them equal to each other. So x minus 3 was the original. And we're going to set that equal to our perpendicular equation, which was negative x minus 13. Cool? Now we solve. I'm going to move over the negative x and get 2 x's there. I'm going to move over the negative 3 and get negative 10. Again, I added 3, so that's now a negative 10. We cool with that? Awesome. Now I'm going to divide by 2 and find out that x is negative 5. So they intersect at negative 5 comma something. That's going to be our midpoint. I'll move this over. The way I figure out what the other part of this is I plug in negative 5 to the original equation. Or the red equation. I'll plug it into this one since it's right there. What's negative 5 minus 3? Negative 8. Okay, so they should intersect at negative 5, negative 8. 1, 2, 3, 4, 5. Down 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so yeah, I just drew my line really poorly. Oh, no, you can't see. 1, 2, 3, 4, 5. 1, 2, 3.
There you go.
That's
1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. So I just drew my line really poorly, right? That's all. It was a nice number. So now I know where the intersection is. I can use that intersection to flip my point across it using midpoint formula. What is midpoint formula?
Average of the x's.
Average of the y's, right. So midpoint is average of my x's, average of my y's, and of course we add when we average, right? Add and divide by the number of pieces. Stay with me, we're almost done.
Sorry.
So I know midpoint is negative 5, negative 8. That's what we just got. I know one of my x's and one of my y's is going to be the point I'm looking for, and the other two are the original point. Negative 2, negative 11. So negative 2 for the x, negative 11 for the y. Now I do math. I'm going to write this out so everybody's with me, okay? This should equal negative 5. They go together. So I know negative 5 equals x. What's x plus negative 2? There's a better way to write that. Minus 2 over 2. How do we solve a problem like Maria? Get rid of division.
It's 2.
How do we get rid of divide by 2? Carpenter. How do we get rid of divide by 2? That's right. So I get negative 10 over here equals x minus 2. How do I get rid of a minus 2? I add it, so I get negative 8 equals x. So a prime, our reflected point, is going to be negative 8 comma something. How do I find the other something? Well, right here. These go together, right?
Yes.
So I know times by 2. Oh, I'll write it out. Y plus a negative 11. Isn't that just y minus 11?
Yes.
Times by 2, I get negative 16. Add 11, I get negative 5. Schlaffer, are you with me? That's where a prime is. Negative 8, negative 5. Negative 8. 1, 2, 3, 4, 5, 6, 7, 8. Down 5. 1, 2, 3, 4, 5.
Boom.
If my blue line was drawn better, it would be equidistant.
Wait, so does that mean like
It's a little lopsided. My blue line's bad.
if you were to raise the red line up, does that mean that blue dot would be your midpoint, and then you know what I'm talking about, or not?
If I were to just shift this for no reason,
Does that
yeah,
mean-
I could change things, yeah.
What?
Depends on where A is,
We finished the quarter.
right?
Well, right.
But really, my blue line's the thing that's off. It needs to be moved down a little bit. How do you feel?
Bueno.
Here's what we did. We graphed the blue line. We graphed the green point. We took the slope, flipped, and negated it. We found B by plugging it in. Then we graphed that.
What number 10?
Then we found where they intersected by setting them equal to each other.
Yep.
Then we took that intersection point and plugged it into midpoint.
I'm putting it all on the table. Number 10.
Who's you?
8.
Oh, you should do number 10.
No, we can't do number 10.
Too much.
You're like
I'd rather not.
Is this just what we just did again? Just funky
Same thing,
numbers?
but there's one thing we need to talk about. So I'm going to do it really quickly. You're not going to write anything. 1, 2, 3, 4. Down 1 over 3. That's our line. It's going to be gross again. Sorry.
My ex-wife.
1, negative 3. That's A. We cool with that?
No, yeah.
Our perpendicular line. When we flip 1/3, what do we get? 3 over 1, which is just 3. It was negative, so what's it going to be now?
Positive.
So it's 3x plus b. When we plug in 1 for x, and we plug in negative 3 for y, it turns out b must be negative 6. So we have 3x minus 6. That is our perpendicular line. I go down 6. 1, 2, 3, 4, 5, 6. And I go up 3 over 1. Perfect. A goes through it. There's our line of our perpendicular. Then what we're going to do is figure out their intersection point. Here's where things get tricky. I'm going to put those two equal to each other. So watch. 3x minus 6 equals negative 1/3 x plus 4. Here we go. Buckle up. I'm going to add 6 to this side. I get 10. I'm going to add 1/3 x to this side. What do I need to add those together?
So there's not two variables.
Common denominators, right? They're both x's, so we can put them together. We need common denominators. So the question is, how many thirds are in the number 3? 9 thirds, because 9 divided by 3 is 3. All good. Another way to think of it is 3 is just 3 over 1. How do I make the 1 a 3? I multiply by 3, right? So I multiply by 3 to the top as well. That's common denomies. If I've got 9 thirds and you have 1/3, how many thirds do I have? 10 thirds x equals 10. Now we have a choice. We can either get rid of the divides by 3 or the times 10 first. Which do you want to get rid of? I prefer to get rid of the division.
Let's do that.
How do we get rid of divide by 3?
Multiply.
We multiply by 3. So I get 10x left over on this side and 30 on this side. Again, that's 10 times x. I got rid of the division by multiplying, right?
And then divide.
And then I divide by 10 and x is 3. So we have 3 comma something for our midpoint. I plug 3 in. What's 3 times 3?
9,
Minus 6 is
5, 3.
3. So I must have an intersection at 3, 3. Turns out I do. Awesome.
Now midpoint.
Then I do midpoint formula. 3, 3 is going to equal our average of the x's, average of the y's. When we average stuff, do we add or subtract?
Add.
We add. Good. So we have x and y that we're looking for, and then we have our original point. 1, negative 3. 1 for x, negative 3 for y. Let's do the math in our heads. This should equal 3, right? Get rid of divides by 2. What do I do? Times by 2. That's a 6 now. I subtract the 1. 5. This equals that. I times by 2. I get 6, right? Do I add or subtract the negative 3?
Add.
I add the 3. So I'm at 6. And I add 3. 5, 9, which is my height. 1, 2, 3, 4, 5. And then up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9.
Where do you need me?
How you feel?
So.
Plot the stuff. Change the slope. Find your perpendicular. Set them equal. Find where they intersect. Use that intersection in midpoint formula. Average of the x's, average of the y's. Friday's tomorrow. Quiz day.
You.
It's a good day to die. All right.
A good day to die. All right.
Last grade before your report cards go out.
What's your favorite movie?
My favorite movie? That's a great question.
How about 50 Shades
The
of Grey?
best movie I saw recently was, let me pull out my list. I keep a list of all the films I've seen recently and give them a thumbs up or thumbs down. Let's see.
Rotten Tomatoes.
Stranger Than Fiction, which I've seen multiple times. I also watched Moulin Rouge recently, 2 thumbs up. About Time, 3 thumbs up.
Never heard of
Who's
it.
ever seen About Time? You need to see it. It's one of the greatest movies of all time. It's also a rom-com, but it's still a great movie.
You're not a superhero guy?
I'm a big Steve Rogers fan.
Really?
Yeah.
I'm more of a